Okay, guys, so what we're going to talk about today are the conic sections, in particular parabolas. So there are different conic sections, and we're going to start off with the easiest of the three that you're going to study, which is the parabola. And there's a lot of lingo here. So let me move my lighting because it's a little off there. There's a lot of, this is going to be a lot of information. Um, so I'm not even going to give you, I mean, I have homework assigned on WebAssign, but I'm going to give you extra time to do it. I want you to mull this over a little bit. And more importantly, I want you to really know the definitions and you need to know the formulas. All right. So if you were going to take a semester exam, and I'm thinking of giving you one of my own. In this case, with this situation, you could have access to notes and I wouldn't know, so whatever. But on the real semester exam, they don't give you any formulas for this, and when you see the formula sheet, your eyes are probably going to pop out of your head. So we're going to take this nice and slow, and hopefully, if you have any questions, you will let me know so that way I can address them. Okay, so let's first start out with the definition of a conic section. And a conic section is just a figure that's formed by the intersection of a plane and a double napped cone. And you may be saying, well, what's a double napped cone? Well, I just pulled these off the internet and I only have a laser printer, so it only prints black and white. But the cone part of a cone is called a nap. So when you take a cone and an inverted cone and touch them vertex to vertex, that's called a double napped cone. All right, so no big deal. And depending on which way we slice through with a plane, if we slice straight across, we're going to get circles, okay? And so these are the basic conics right here. And you studied the circle to some degree. These are the ones we have to finish up with, the parabola, the ellipse, and the hyperbola. Um, you get an ellipse, when you have, I don't know, some degree of slant there and you cut through, you get this oval shaped thing. That's not a circle. Parabolas, if your plane cuts part of the conic, you get these parabolae. Okay, you could have another one down here too. And finally, the hyperbola, you've got this sort of straight up and down plane cutting through the edges, and you end up with something that kind of looks parabolic, but it's not. All right. And then the other thing you should know, well, I don't know if you need to know it for this class or not, but it's worth just mentioning that if the plane actually passes through the vertex, so in all of these, the plane doesn't touch the vertex, it doesn't intersect the vertex. But here, if we stick our piece of paper, think of the plane as a piece of paper, directly in between those two vertices, what we're going to have is a point, right? And if we do the plane this way along the conic, we're going to have a line. And if we did two planes, we would have two intersecting lines, right? So those are called degenerate conics, and we studied those in geometry, right? The three undefined terms in geometry, a point, a line, and a plane, right? Remember that? So anyway, that's what a conic section is. It's these two cones that touch at their vertices, and they're sliced by planes in at different angles, and you get these conic sections, which we can describe as a parabola, an ellipse, or hyperbola, depending on the characteristics of it. All right. So now let's look at the parabola. A parabola is a set of all points x, y in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that's not on the line. Whoa. So, thank goodness for the internet, right? I can just hit the print key. So, here's a parabola, okay? You remember these as quadratics, right? They open up or down, right? Yada, yada, yada. And its vertex, this picture here, the vertex is on the y-axis somewhere. Oh, excuse me. This is the origin, okay? So let me read it again. Let me just move my notes and I'll read it word for word because that is the formal definition. It's the set of all points x, y. So every point on this parabola represents an XY coordinate or a point, right? This could be the point here, x sub 1, y sub 1, and this one could be x sub 2, y sub 2, right? This could be x naught, y naught here, and we could find another point here and here, and whatever points we want, okay? So these are the points, the set of all points, so every point along this curve here in a plane. Well, my piece of paper is a plane, so these points are in a plane, okay, that are equidistant, meaning the same distance from a line called a fixed line called the directrix. So this dotted line here, this thing, this is called the directrix. And what I want you to see is that these points on the curve are equidistant from both the focus and the directrix. So the distance between the focus and this point is the same as the distance between this point and the directrix. Make sense? And the distance between the focus and this point is the same as the distance between this point and the directrix, and so forth, right? I could go on and on. The distance between this point and the vertex in this case, so the focus and this point, which happens to be the vertex, is the same as the distance between the vertex and the directrix. And I could go on and on. I could take any points that I wanted to, and this line would be the same length as this one. This distance would be the same as that one, and so forth. So that's all that formal definition means. All right. Now, the parabola has something called an axis of symmetry. And the axis of symmetry is just a line that passes through the focus and the vertex. So, you know what? I'm going to see if I'm going to print another copy of this thing while we're discussing. File, print, page 2, print. And because, this is getting involved here with all of my workings, but the axis of symmetry is just a line that goes through the vertex and the focus. So in this case here, the y-axis would be the axis of symmetry. Okay, the axis of symmetry by definition is a line. In fact, this one here would be the line x equals 0. Vertical lines are of the form x equals whatever x coordinate they go through, right? So this is a line, a vertical line called x equals to 0 in this particular case. And this axis of symmetry cuts the parabola into two congruent pieces, right? Or two equal halves, two of the same. Mirror images is what I meant to say, okay? And you notice that the focus and the vertex are both on that axis of symmetry, and that will always be true, whether this thing opens up, down, left, or right, which you're going to see in a few minutes, okay? The other thing is that the axis of symmetry is always perpendicular to the directrix. So these two are perpendicular. Shoot, I'm not paying attention to my video. I'm still on the other screen. So these two are always perpendicular to one another. Okay? And also you should know that the vertex is the midpoint between the focus and the directrix. So a minute ago, I said that, the distance from the focus to this xy coordinate to this point is the same as the distance from the point to the directrix. And then I went over here and I said the distance between the focus and this point here, which happens to be the vertex, is the same as the distance between the vertex or this point and the directrix. Well, guess what? That means that the vertex is the midpoint between the focus and the directrix. And that's nice because that's going to help us a lot when we have to write equations. Okay? And anyway, it's the midpoint. Never forget that, okay? The focus is just a fixed point on the interior of the parabola, so it's always inside the parabola. The focus is always inside the parabola, and it's going to lie on the axis of symmetry. We say p units from the vertex, all right? So we call this distance here p, and you'll see why in a few minutes. And then the directrix, of course, we already said, is a line that's going to be perpendicular to the axis of symmetry. All right, so if my parabola opened like this to the right, And my axis of symmetry has to go through the vertex, and the focus always has to be inside, so it's some fixed point somewhere in here. Then I know that my directrix has to be outside and perpendicular to that. All right, so it's a line perpendicular to the axis of symmetry, and it never touches the parabola. So the directrix never touches the parabola. Okay, so again, I'm just going to put this in view. These are the quick notes I made. That way, if you're watching at home and you want to stop the video to take notes and digest it a little bit, you can do that. All right. Or you can press the pause key or do whatever it is you want to do. But anyway, so these are the notes. So it started with the conic section, the definition, right? I showed you the picture of the conics being formed by the intersection of the plane and the cones. And then we have the definition of the parabola and its characteristics. Okay. So now, remove these and let's go to the equations. Okay, focus isn't going to happen. Okay, so again, this is going to be overwhelming for some of you, so I'm going to give you some time to digest it, but I can't give you too much time because remember, I have to cover a curriculum, okay? And so do you. So there are many equations of parabolas. As you can see, there's 4 here, it looks like, right? There are 4, but there are more that you're going to see in a minute. The important thing is that the equations here, which is in this column, these are all parabolas that have their vertex at the origin, okay? And you need to know these. And, you know, you can work with these little charts. In fact, I'm going to modify one of the charts that I made to include this. It's just kind of a weird thing to include. When you see the other chart, you'll see why. All right, so here's what we need to know. I'm going to go through this. Again, all of the vertices here are at 0, 0. The focus is going to be at the point P0. The directrix will be the line x equals to negative p. The equation for something like this is going to be y squared equals 4 times p times x, which means the direction that the parabola will open is to the right. And the axis of symmetry is going to be the x-axis. Okay. So, you know, it's going to look something, oops, here's the y-axis, the x-axis, and maybe something like that. Okay. Oops, you can't see that. Sorry. X-axis, y-axis. My parabola has its vertex at the origin. And according to this thing has to open to the right. The focus is going to be somewhere in here. The directrix is going to be somewhere out there, right? This is the x-axis is the axis of symmetry. And I'm going to show you some better pictures in a minute because, you know, I can't draw, so I just copy pasted out of the internet. But the important thing is that the equation is given by y squared equals to 4 times p times x, right? So guess what? If the parabola is going to open left, it still has pretty much the same equation, except when it opens left, the coefficient here is going to be negative 4. All right, so again, we have our vertex at 0, 0. You notice the focus here, that p, which is that directed distance between the vertex and the focus, it was positive here, it's negative here. The line for the directrix is going to be the line x equals p, whatever that value is, and you'll learn how to find that in a minute. The equation is y squared equals to negative 4px. It's going to open to the left, and again, the x-axis is the axis of symmetry. So that one, if this is the xy axis, would open or look like this. My focus would be somewhere in here, my directrix would be somewhere out here, and it would open to the left. Now, the up or down versions, right, the type you're used to. Again, if our vertices are at 0, 0, the focus for this one is 0p. So you notice these sort of just reverse, right? They swap places, kind of like an inverse would do, right? But not quite. The directrix now is the line y equals to p. This is a horizontal line. X equals a number, that's a vertical line, right? So the directrix here would be a vertical line. The directrix here would be some vertical line. Well, now what's happening is we have the lines y equals, so that means that our directrix is going to be oriented such that it's horizontal. The equation for a parabola that opens up is x squared equals 4py, and the axis of symmetry is the y-axis. And then likewise over here, the sign of p changes. The sign of p changes again for the directrix. The equation's almost identical, except now we have a negative out front here. In this case, it's going to open down. And again, the axis of symmetry is going to be the same. So if it opens left or right, the axis of symmetry is the same. The equation's almost the same. Left or right starts with y, okay, y squared. The directrix, if it opens right, is going to be negative p. If it opens left, it's going to be positive p. The focus will be p0 for the parabola that opens to the right, and the one that opens to the left will be negative p0. So again, I know this is a lot, and we haven't even scratched the surface yet. So let's take a look at a quick example. And by the way, let me show you here this little chart I printed. Oh no, that's not the one I wanted. Hang on. Oh, so many notes and so little time. Is that the one I printed? Darn, I printed the wrong one. Oh, no, I didn't. Okay. So, normally directrices are done with dotted lines, so I was thinking this was the x-axis, but it clearly says the vertex is at 0, 0. All right, so you can use this along with that little chart I wrote up there. All right, you notice when p is a positive number, your parabola is going to open up. When it's negative, it's going to open down, and the general equation is this right here. Now, if p is negative, you're going to get a negative out here. Makes sense? So it's the same equation, all right, but the p value is negative, and we bring the negative out front. Okay, the vertex here is still at 0, 0. The directrix here is the line y equals to negative p. Y equals to negative p. The directrix is horizontal line. The axis of symmetry is a vertical line, right? The focus is always inside the parabola. And then when you have the other case, whether it opens left or right, again, you've got the same equation. It's just, remember, one's positive and one's negative according to the chart, right? And that happens because of the value of p, the sign of p. So if that p value, that directed distance between the vertex and the focus, is positive, then your parabola is going to open to the right. And if it's negative, your parabola is going to open to the left. Okay? And then they give you the little equations here for the directrix, the focus, coordinates for each one. So you may find this little chart helpful as well. Big thing is that kids always get confused between, is it x squared equals 4py or is it y squared equals 4px? And if it opens up or down, it starts with x squared equals 4py. So if there's an x here, there has to be a linear y over here. This is the quadratic term, right? This is the linear term. On the other hand, if it opens left or right, it's going to start with y squared is the quadratic term, so to speak, and x is the linear term. All right. So let me go to, I just want to find my other table, a little example, this one here. So it's right here. Let me just move those papers out of the way. Okay, so it says, so forget about what's below it. Okay, it says analyze x squared equals negative 12y. So I'm going to bring this chart down a little bit, so that way it's in view. We want to analyze this. Well, first of all, this thing starts with x squared. So I know this is going to be a case where my parabola, I might not know much about it yet, but what I do know is that this thing's going to either open up or down, right? I know it's a parabola. I know it's going to open up or down because it starts with x squared. Makes sense? So that's what I know there. The other thing I know is that I've got a negative out here, right? So remember, the formula is, or the equation is x squared equals negative 4 times p times y, right? And that means that my p-value must be negative. But, rather than that, what I can do is I can say this is x squared is equal to negative 4 times p times y. Now, why did I just rewrite that twice? To let you know that this is a 12 here. And so what I'm doing is I'm saying, how is negative 12 equal to 4p, negative 4p? I can find my p that way, okay? So in other words, my p is combined in here. All right, and so guess what? My p-value is 3. So what I have here is x squared is equal to negative 4 times 3 times y. The other thing I know is that my vertex is at 0, 0, so I could make a quick sketch, and I already did that, so I'm going to show you. I made the x and the y-axis, and I plotted my vertex at 0, 0, because that's what I knew, all right? Now, the other things I know from this thing, besides the vertex being 0, 0, is I know that p is 3 because I just found it. And I know that p is the directed distance between the vertex and the focus, right? So this here is my p, and it's 3. All right? So I know then that my focus is located at the point 0, negative 3, because the focus always has to be inside the parabola, right? And my focus is inside the parabola. The other thing that p-value tells me is, remember, since the vertex is the midpoint between the directrix and the focus, that also means that this distance here must also be 3. So the directrix is going to be the line y equals 3. Remember, it's a line, okay? It's not just 3, it's y equals 3. The other thing I know is that it's going to open down. How did I know that? Well, because we had a negative there, all right? And the axis of symmetry, according to my table, has to be the y-axis, and as you can see, it is, all right? And so you can generally, they're going to give you enough information where you can at least maybe plot the vertex and the focus. And then you may have to find that p-value and then determine, look, if you plot the vertex and you know where the focus is, then you're going to know if it's going to open up, down, left, or right. All right? But that's just a way you could look at something like that and analyze it. Just based off that little bit of information, I could just say, hey, I've got the vertex. I know the focus is inside. Let's see, how can I find the focus? And so forth, okay? Well, I know that the focus is the point 0, negative p, right? And it turned out that that was 0, negative 3. Okay, let's look at another one. And I want to cover it. So this one says, find the equation of a parabola with focus at 0, 4 and directrix y equals to negative 4. So heck, I have to find the equation, right? I don't know if this thing opens up, down, left, right, but guess what? I can find out. If this is my x and y axis, and my focus is at the point 0, 4, so there's my focus, and my directrix is at the point 0, negative 4, 1, 2, 3, 4 in the negative direction. This is my directrix, the line y equals negative 4. Then what I know is that the vertex is the midpoint between those 2 points, right? Or between this line and this point, right? So my vertex has to be at 0, 0. This is my vertex. Now, since the focus has to be inside the parabola, And that means that my parabola is going to open up because the focus has to be inside the parabola. Now I have to find an equation, right? So I take my little table and I say, okay, I've got a parabola that's opening up. Well, that would be this equation, right? X squared equals to 4py. And I know what my focus is. I know my vertex because I found that. I know what the directrix is. I know it opens up. I know the axis symmetry is the y-axis. All I have to do is write the equation. Okay. Well, before I write that equation in its entirety, we've got, let's see, let me just write it down. 4py, right? I know what my p-value is too. My p is the directed distance between the vertex and the focus, and that was 4 units, so p is 4. So what I have is x squared is equal to 4 times y, or x squared is equal to 16y. And I'm done. I wrote the equation. I may have had to look at my little table a little bit, but guess what? That's going to be normal to begin with. And here's a better rendition, because I already did the work. And I put some little notes here. Don't forget. And I wanted to state this. Vertex is halfway between F, which is the focus, and D, which is the directrix. So I just used some shorthand so I wouldn't have to keep writing it over and over, because it is a pain. Here's one last one with a vertex at 0, 0, and then we'll talk about some craziness. So let's find the equation of a parabola with a vertex at 0, 0. Axis of symmetry is the x-axis, and the graph contains the point negative 1/2, 2. Yikes. That's different. No, it's not. Okay, I know my vertex is at 0, 0, and that the axis of symmetry is going to be the x-axis. So far, what I know is that this thing's going to either open left or right. It's either going to open this way or it's going to open this way, right? I don't know yet, but I know my vertex is on there. My axis of symmetry is the x-axis. The other thing I know is that the graph contains the point negative 1/2, 2. Well, where's the point negative 1/2, 2? If I start at the origin, I go over negative 1/2 and up 2. This is a point on the curve, on the graph, on the parabola. So what I know is that this parabola has to open to the left because this point is in quadrant 2. Interesting. Well, now I got to find some other stuff. I got to find the focus, the directrix, and graph it. Geez, how am I going to do that? Well, like this. This is what we know. We know the vertex. We know the axis of symmetry. We now know that this thing opens to the left, right? Because this point is on the curve and that's in quadrant 2. And if it opens to the left, then this is the formula I need to use according to my table, my chart, right? And so because they gave me a point, I can plug in the x for the x and the y coordinate for y, and that's going to help me solve for p. So I've got 4 is equal to negative 4 times p times negative 1/2. Well, negative 4 times negative 1/2 is a positive 2. So 4 divided by 2 gives me a p-value of 2. So now that I have the p-value, I can plug that in. And I've got y squared is negative 4 times 2 times x, or negative 8x. This is the equation of the parabola whose vertex is at 0, 0 and opens to the left. Now, I didn't find the focus or the directrix because I forgot when I was preparing the notes, but let's do it now. So here's the x and y axis. My vertex is at 0, 0. This thing opens to the left, right? Now, this p-value of 2 is very important. Why? Because I know the focus is p units from the vertex. So my focus here is at the point negative 2, 0. And my directrix has to be equidistant from the vertex. And it's going to be the vertical line x equals 2. You see how that works? So once you play around with them, you're going to get better and better at it, I promise. It just takes some practice. This is not something you can blow off and learn at the last minute. There is no way. And I'm going to show you why right now. Because not all parabolas have their vertices at the origin. We have something called the standard equation. Where's my other table here? Here it is. We have something called the standard equations of parabolas whose vertices are not at the origin. Don't worry about the ellipse or anything else on this page right now. Yikes, right? Not only do you have to memorize all those formulas, and let me get that little sheet and put it under it so we can compare. Actually, it would be better if I do it like this. See if I can fit all of that in here. Boop, this way. There we go. Yeah. Okay. Not only do you need to know all of those, but you need to know all of those. And you're like, OMG, this is crazy. Yeah, it's a little bit crazy, but guess what? All students get used to it. So you just got to get used to it. So let's have a look at this. If your vertex is not at the origin, then the vertex is at the point HK, all right? So I want you to notice right here, vertex. In each case, the vertex is at HK. And this is caused by vertical and horizontal shifts, okay, of the parabola, moving it horizontally in the x direction, either right or left, and vertically up or down. We call that the k direction, okay? So the vertex is at some place other than the origin. Then these two apply. Well, you're going to have a vertical axis or a horizontal axis, depending on whether it opens up, down, left, or right. All right. So the equation for the vertical axis is x minus h squared equals to 4p times y minus k. Now, I want you to look at this. This is if the h were 0, so if hk were 0, 0, and I plugged a 0 in there, I'd have x squared is equal to 4 times p times y, right? That would be this one right here. So what do I know? Well, if p is positive, my parabola will open up, and if it's negative, it's going to open down, all right? The axis of symmetry will be the line x equals to h. So you just take, x minus h, set it equal to 0, and solve for x, and that'll give you your axis of symmetry. Or just change the sign from what you see, and that'll give you your axis of symmetry. The focus is at the point h, comma, k plus p. The directrix is the line y equals to k minus p. And again, if p is positive, your parabola will open up, and if it's negative, it's going to open down. So opening up or down depends on the p-value. The focus will still always be inside the parabola. The directrix will always never touch the parabola. The focus will be p units from the vertex, wherever it may be, and the directrix will also be p units from the vertex, wherever it may be. Okay, it doesn't matter if it opens up, down, left, or right. Now, if the axis of symmetry is horizontal, then what you have here, so horizontal, right, the x-axis, it's going to be one of these two, right? Well, guess what? I've got y squared is equal to 4p. And again, if you thought of h and k as 0, 0, you'd have y squared is equal to 4px. So it's not 0, 0, and these are called the standard equations for a parabola. Again, there was some kind of a vertical and horizontal shift. The difference is that here for vertical, it's hk in that order, alphabetical order. And for the horizontal axis, it goes kh, so they swap. The axis of symmetry here was x is equal to h. Here it's y equals to k. Vertices are going to be the same. Now look here, the focus on the vertical axis is the point h comma k plus p. Guess what? The point on the horizontal axis is h plus p comma k. So you see with these symbols and how they're swapping around, it can get very confusing. the directrix here was k minus p, and the directrix for the horizontal axis is x equals h minus p. And then if p is positive, this will open to the right, and if it's negative, it'll open to the left. Okay, now I'm just going to give you a quick glimpse, not to scare you, just to show you your reality. These are formulae for the ellipse. These are formulae for the hyperbola. Those are the other two you're going to eventually learn, okay? So that's why I say it's going to seem overwhelming. All the symbols are going to sort of scramble in your mind. Don't let that scare you. You just have to practice a lot. And if you promise to practice a lot, I promise you that you will get it. It's all about practice. So let's see. Yeah. Let's do one example and then I'm going to stop because again, I don't want to like make you cry. Okay, so again, the standard equation where the vertex is at the point HK, it's not at the origin. Okay, there, it's caused by horizontal or vertical shifting of the parabola, and I put C chart because you're going to see chart. And I'll post a copy of this on Edsby for you tomorrow. It's almost 10 o'clock right now, so I've been working since like 5:30, so I'm getting ready to go night. So I'll post it in the morning. So here's an example. It says find an equation of a parabola with the vertex at -2, 3, the focus at 0, 3, and graph it. Okay. So what I try to do always, if I'm working with conic sections, is make a sketch of what of the information that's given, because a lot of times you can put it into perspective and figure out a bunch of stuff if you do that. So, and I always think about what do I know? Well, I know the vertex and the focus lies on the same horizontal axis, and that axis is the line y equals to 3. How do I know that? Well, if I plot the point, so I'm going to do it over here. I tried to make a nice picture, but I'm going to do it over here. If I go to the point -2, up 3, and I plot my vertex there, again, at this point, I may not know if it opens left, right, up, or down. That's okay. I have my vertex, and I know my focus is at the point 0, 3. Well, that's right here. Well, guess what? That means my parabola has to open to the right because the vertex and the focus always lie on the axis of symmetry, right? And the y values are the same. They're both 3. So I know that this is the line y equals to 3. That's my axis of symmetry. And since the focus always has to be inside the parabola, my parabola is going to open something like that. So here's a better picture. It's not much better, but it's better. Okay, so I figured that out just by some logic, right? Then I remember that P is the distance from the vertex to the focus. So essentially all I have to do is figure out that, if this is 2 units, right, away from each other. So I have my P value, it's 2. And guess what? I know my directrix never touches the parabola, and it's going to be the same number of units, 2 units to the left in this case. So it's going to be the line x is equal to 4. 1, 2, 3, 4. All right. And then I'm just validating what I know is that my directrix is always perpendicular to my axis of symmetry. So I've got my graph. So look, now I need the equation, right? That's the essential part. My teacher wants the equation. So I may be able to graph it and figure out what P and this and that are. But now I got to put it into an equation. And if I'm not using notes, so like last year, you would be doing this without, notes when you take tests. You have to keep all this mess straight in your head. Right? There's a lot of stuff. Well, look, I know it opens to the right. Okay, so it's going to be this one, right? It has a horizontal axis. It's got to be that equation. So just based on those few characteristics, I know that my equation is going to be y minus k squared equals to 4p times x minus h. And guess what? At this point, I can pretty much plug in my excuse me, my K, my H, my P, because I know what that is, and I've got my equation. So that's what I did. I wrote down the standard form. I plugged in 3 for K. I plugged in now look, the formula is X minus H. So I just want to stress that when I got this here, I plugged in X minus a -2, right? Because this is a -2 for the X coordinate, and that becomes a positive. So what that gives us is 8 times the quantity X plus 2. This right here is the equation of the parabola with vertex at -2, 3 that opens to the right. Done. So it's all a matter of working with these formulae. All right, so I think that's enough for today. Mull that over, think and wonder, wonder and think. Again, this begins on page 700 of your book. So let's see. You know, it wouldn't kill you, since I'm not giving you any official homework. It would not hurt you to go to, say, page 704, where the exercises begin. Oh, here. Whoa, this is so bizarre. And, you know, try to match an equation with its graph using the little chart that I give you, all right? Try and see if you can figure it out. Or, you know, maybe trying to make a sketch based on they're giving you some information. Maybe you can just try and sketch it and find a p-value or something like that. A little bit of practice, all right? Some of you who are more advanced and who might even know this or pick up on this stuff real quick, you may want to go down into the, you know, 27, 29 area. We have vertices here at, well, there's one at 0, 0, way down here. Way down here, we've got a vertex at 0, 0, but that doesn't matter. It just means that the h and the k becomes 0. So, you know, you end up with x squared equals 4py or y squared equals 4px, whatever. You know, see if you can actually write the equation. That would be helpful to you for next time, because next time I'm going to go back over this. In the meantime, so between now and the next time we're supposed to meet, which would be Monday, you need to come up with any questions. If you're lost, stuck, you don't know what to do. And the other thing is you need to study the formulas. You know, when does it open left? When does it open right? Which equation goes with the parabola that opens up? Which equation goes with the parabola that opens down, and so forth? Okay. I'm very sorry. It's been a very long day. So anyway, mull that over. Let me know if you have any questions. That's your responsibility. Send me a message through Edsby with any questions that you have about this topic, and we'll review it again on Monday, and then we're going to do some more examples like this, and then I'll assign you homework on this section. Okay? Have a good day.